Hey there, welcome back. I know it's been a long time since how do we say this? I try to make a video that is probably gonna be taking hours, since I usually make videos of hours. But yes, I just came back and I thought that it's time to deliver some knowledge around those smartphones that we are using, and Android is going to be our subjects for today. But the thing is that I think 2 days ago I tried to live stream about this specific subject, which is Android, and it comes out that the quality of the stream wasn't that good. So mainly the problem was that I'm a newbie to OBS and to streaming and to all this shit. So mainly the quality of the stream was the first thing bad, and the quality of the mic is bad and still bad. I know that. I know that it's still bad. But I hope in the future, like, the quality of the videos became better, like with the new mic or something, or maybe adding up some camera. Who knows? Like, I don't know. Like, but yes. So Android smartphones. If you are completely new to reverse engineering, I suggest you just hit the, I know that there's a button out there, just hit it. Just hit the subscribe button for sure. You can follow me on those little links too. And sorry for the bad drawing, I know I don't know how to draw things, so yeah, Android anyway. So motivation. So how can I give you a motivation just to start this series? Okay, I can reflect on my own journey. So mainly for this specific, for example, subject which is Android, I think I hold up around 3 workshops in my university just around this specific subject. But this subject is really interesting, especially nowadays since everyone is using a smartphone that has some technology inside of it. So understanding this technology can make you, let's say, important. Yeah, important, especially if you are trying to find security flows or trying to pen test, for example, applications that works out inside of your Android smartphone. So, for example, like the motivation for me behind this series of videos that I'm gonna be making, and you need to be sure that that you're activating like the notification bell, because a lot of videos are gonna be dropping in the next weeks. So you just have to activate that notification bell of yours just to be sure that you get notified when a new video is uploading or something. So for example, the motivation behind this series of videos was just the how do we say that, the curiosity. Yes, the curiosity is just to understand what those systems are doing. For example, my journey with smartphones started when I was in high school. So I wasn't having like a phone or something, but I was just seeing a lot of smartphones out there. So I had the urge to just try some smartphones just to play some games and stuff like that. But before diving in this world of Android operating system and its application, I was just asking myself, why am I even interested in the first place? Like, what benefits there was to seek, for example, from this specific thing? Why should I, for example, just learn Windows, or I don't know, maybe dig deeper inside of iOS or Apple, or I don't know. That's another subject. For example, Apple products are another like subject. For example, right now I have both the systems. I have the iPhone, let's say the iOS specifically, but I have an iPhone and I have also an Android like phone, so I use them both. And Android seems to be like, as everyone likes saying, it's more open. So it's more open, and yeah, it's for everyone. It's something that is not that like expensive compared to what Apple are giving in the market. But I'm not gonna be like speaking about the economy, about the prices. It's not something important for the video. This is focus. Okay, so I was in high school, so I was trying to understand what those phones are doing. Well, at that point, I didn't have like any kind of knowledge in computer science and programming, anything. I was just playing with the phone, not understanding. For example, I downloaded the application from the um, from the Google Store, and then yes, it crashes, and I don't know why. For example, why it crashes. And I even installed some APKs from the internet that installed also some malwares on the phone, so the language of the phone has changed, and a lot of shit was happening on that poor phone that I was having. So yeah, so this is my journey with Android. So it's been full of malwares and shit, specifically from, especially if you're trying to download something not in the Play Store, or I don't know. So yeah, so at this point I was interested. So that's why, for example, few years ago, so 2 years ago, like to be exact and to be accurate, I tried to enter this journey just to understand. I still understand, I think, zero point 0.8 or zero point 0.7 from like this Android like world out of like 100 for sure. But I think it's really interesting. It's really interesting, and you should be trying to understand what your phone is doing, because it's a really important thing to do. You can't deal with the phone like your whole life, especially if you are in technology and security and you are interested in not just using something but improving its performance. So you should be at least trying to do a reverse engineering specifically on what your phone is doing to fully understand what's the engineering behind it, obviously. Yeah, so that's it. So the first thing that we should be saying is now I think it's time. We don't have to waste too much time. I'm gonna be going straight forward to the Android system, just for you to understand exactly what's going to be happening. So the first thing to say is that Android is an operating system and is also a framework. So a framework is something that is going to be helping you build products for a specific, let's say, operating system or something. So the Android framework. So if you go and type in the Android stack, you see something like this, which is this famous picture. So I've already, I think, explained those things in the latest stream. But if you have, for example, joined the stream and you've been like there for 1 hour or half, this video is going to be, I think, maybe longer, because I'm gonna be explaining all the theory in this introduction, and then in the next video I'm gonna be seeing the APK, and we're gonna be understanding how these Android application are made. So we're gonna be going from outside of this system and then get step by step inside of the system itself to see the applications and how they get built, and how they interact with the operating system, because the world that we are working on right now is the world of Android. So for example, when we were like dealing with binaries and the other playlist, which is the reverse engineering in general, we usually deal with either Linux binaries or Windows binaries, or for example, I don't know, Game Boy binaries, Nintendo binaries, maybe firmwares or whatever. But for this specific thing, we're going to be focusing on smartphones, which are using the Android operating system, which is also going to be building applications using the Android framework. So to be able to understand what the operating system is going to be doing, you need to understand the platform architecture. And actually, Google gives us a good, say, good is just not enough. An amazing documentation of the Android platform. So the first thing to take a look at in the stack is the system apps. So this is the stack of the Android basically. So you have system apps Java API framework, and native C++ libraries, and Android runtime, hardware abstraction layer, and Linux kernel. I'm gonna be trying to go into each layer alone and then try to explain what the layer is going to be having inside of it and what's the role of that layer until we get into the bottom, which is the Linux kernel. So the first thing to say is that if you don't know what a framework is, so a framework is just a collection of pre-built tools and libraries that allow you to create specific project like without having to start like from scratch every time you want to build something new. So this is like a way of saying things. For example, you can imagine it. For example, I don't know. You wanna build a big house out of blocks. So every time, for example, you can just get one block and just put it, and get one block and put it, and then until you build the big house that you want to build. So those blocks are actually, let's say, just going to be using those layers. So this is the analogy. I'll be trying to give as much analogy as I can, just for you to explain, or just for you to understand what this stack is going to be having. So yes, so the thing is that we need to be having a solid understanding of this stack, guys, because if we take a closer look at the Android, for example, the framework, and explore how it works, and because that's the thing, most of the Android applications are going to be using one of those layers, or maybe two layers, or maybe three layers at a time. Who knows? So that's the thing. So you should be taking a look at those layers before you try to do anything. So if you are learning, for example, mobile security from scratch, let's say you are trying to learn, for example, how Android works. For example, mobile specifically, mobile stack is based on an understanding those concepts first, and then try to get into the code, try to get into Java, try to get into Kotlin, try to get into whatever you want. So the first step is to fully understand how things work, and then practice games just to adjust the knowledge that you have. That's something I do believe in, to be honest. Maybe someone else might just say to you, go in, take the application, throw it into a decompiler, and then boom, you have like the code, and then you are reverse engineering. No, I think anyone can do that, but understanding like how the system works and those things is really important. So you can just deny the fact that those people that really understand how systems work are not gonna be interested in the theoretical part, because you love it or not, the theory has some role and has some importance, and the importance of the theory is as important as the practice. So you should be caring about the theory too. That's something I do believe in. Maybe I'm wrong. I don't know. Maybe just that's what I believe in. Anyway, yes. So we can now dive in. Enough motivation, I think. Yeah, for the system apps. So this layer, guys, is just responsible just for providing the core functionality. So before just I try to get into explaining each layer, I want to just pinpoint just something that this is like the higher layer, and the just abstraction layer is just a bridge between the higher layer and the lower layer. The lower layer is the Linux kernel. I'm gonna be explaining that later on, but there is a higher layer and there is a lower layer. Anyway, so the system apps is a layer that is responsible just for providing the core functionality to the device. So like this system apps, for example, such as the email, calendar, camera, or whatever, are going to be used by the system itself to make sure that the core functionalities of the phone is working well. So, for example, when you buy a new phone, what do you get, for example, when you open up the phone? You usually find a camera application, a calendar application, an email application, a dialer application. So those are the, we call them like the system app core applications. So we usually find them at the higher level of the stack. Okay, so they are also, by the way, designed to provide like critical services, such as, for example, we have, for example, if I remember that right, we have the device like battery life, for example, for the phone itself, just to make sure that it's checking the battery life of your phone. So, for example, there are system apps such as this one to check up the battery life of your phone. If it's, for example, in a bad situation, it's going to be telling you that it's in a bad situation. Otherwise, it will. You can find that even I think in iOS systems in iPhone, where it checks the health of the battery. So those are the system apps. Okay, so those that games with your phone. We also have the Java API framework. So the Java API framework layer is like a toolkit. So it's just for developers. So yeah. So this is the place. So the system apps is just for. So that's the thing. As a casual user of Android, you don't know. You only know just the system apps. For example, if you became a developer, you know the system apps and you know the Java API framework. So the Java API framework is just for developers who want to create their own apps. So it provides for them like pre-built libraries, APIs also they can use to make their applications. It includes also components like, for example, buttons, text views. I don't know, for example, layouts maybe, wallpapers. I don't know, like a lot of things to give. So this layer is also having some specific, let's say, special classes. So for example, storing data, communicating over the internet, working, let's say, for example, with things like photos, videos, whatever. So one thing, like, for example, to mention, guys, for this specific layer, is that the Android API means you can invoke an API that is there is, for example, in the Android API framework, you might invoke, I don't know, a method or an API from the Java API framework. So that's the thing. So you can get, for example, a function that is already pre-built inside of Java and call it inside of your Android project. So it's somehow using just the Java as a way to make things. Maybe who knows? Maybe the Java itself is going to be using other also functionalities to communicate, for example, with your camera. We will see those details. I don't want to like talk about them right now because we will see them. So step by step, you will understand exactly how the phone is working. So okay, so we can say, for example, there is a good example of how we can use, for example, an API, a Java API, for example, inside of your code. Let's say, for example, you want to connect to a website using your application, your Android application. For example, to do that, you can just type in URL. For example, I'm gonna be just setting up my blog, but with a one, and you make an HTTP connection. So by creating an object from the class HTTP URL connection, I'm not gonna be taking the too much dive inside of the code. You can just, that's a simple code that communicates with the server, or specifically connect to a web page inside of your browser. So it creates a buffer and then it reads in the content of that page. Otherwise, it disconnects. If it tries that, if there is an exception, it just catches that exception inside of the finally block. So this is just mainly pure Java. So if you don't know what Java is about, then you should go and learn Java and came back. Because if you don't know anything about Java, then this is gonna be a problem. So one of the few things that you should know is Java, especially if you want to understand what those applications are gonna be doing when we will be diving inside of the reverse engineering part. Anyway, so yeah, next, we have the native C++ libraries. So those are like pre-built also libraries. For example, the OpenMax AL, the OpenGL ES, the Media Framework, the WebKit, the libc, whatever. So those things we're gonna be using them. So those libraries are going to be the way that will let us try to communicate with, let's say, the lower part of the stack, or specifically with anything that has access to the hardware. So, for example, let's say, I don't know, you want to communicate with your camera, with the component, with the hardware component. So, you need a way to do that. So, as a developer, you should be having something or a library that can let you from the above side or from the higher side to communicate with the lower side. So, you can just imagine it as a driver. So, the drivers, for example, when you try to build them, you usually integrate them inside of the kernel of the operating system. When you install them, actually install them, they got installed for Linux specifically. I don't know about Windows, maybe it's the same thing. I don't want to give an information that I don't know about, but for Linux, you usually take the driver and just put it inside of the kernel of the Linux, and so that when the kernel is loaded inside of the memory, and it requires to get some any kind of information from the hardware itself, it goes to the driver and asks him, hey, can you try to drive this shit for me? And so this is basically what's going to be happening. So for example, drivers, we integrate them with the kernel, as you can see, for example, in the last layer. But for the native C++ libraries, we're gonna be the developer is the one that is going to be using them. So yeah, so for example, OpenMax AL is going to be letting him do some specific thing. WebKit, same shit. libc, same shit. So for example, libc is having multiple functions, for example, in C and C++ that can let him do some syscalls. And if you remember and you have watched the playlist of the reverse engineering, you should know really well what syscall is and what a syscall is and understand that. But I can remind you of that. A syscall is a way to let you go from the user mode to the kernel mode, or from the user space specifically to the kernel space. So yeah, this is what a syscall is, but a lot of things you should just care about, specifically when you are trying to reverse engineer. And one of the few things is that whenever you are working with a native application that is going to be using native libraries, then you are more into reverse engineering C++ and C code than reverse engineering Java. And we will see that in a better video in this series. There is a video about native libraries, that's for sure. There is a video that about native Android application, and I know enough that there is a lot of people that are waiting for this video, especially those CDF players that are going to be dealing with them. 'Cause since they are one of the hardest part when you are playing any Android, let's say challenge is to get inside of the native Android application, extract the library, and reverse engineer it. So that's the C++ reverse engineering challenge for me. It's not an Android one, but yeah, we will also see that. The Android runtime. So the Android runtime is where the code that you have created will be executed. So the Android runtime is a virtual machine. So we also just call it ART. So it's a component of the Android operating system that is responsible just for running Android apps. So it's a virtual machine that executes code written in Java or Kotlin programming languages. Uh, Just wait a second. What is a virtual machine? I know some of you might just ask that question, but I think I've already explained what a virtual machine, and I think there's also a challenge inside of the reverse engineering playlist about virtual machine with 3 hours or something, where I tried to reverse engineer fully an example of an easy virtual machine. It's not that hard, I suppose. Yeah, I think it's a medium one. I just forgot, but there is a video about that. You can just check it out to understand fully what a virtual machine and see it on practice how it's going to be how what is going to be doing exactly. So yeah, you can just check out that video. So it's the same like a sandbox or something. So it's just a virtual machine. You can just go into the internet and check it out. So Android runtime is a virtual machine that is going to be executing the code that will be generated. So just one thing to understand that it's a magical box. Anyway, it's a magical box. It's going to be executing the code that will be generated for the application. So I'm not gonna be saying the steps on how the generation is going to be done because that's in the next video. Either way, you can for now just imagine that the code that will be generated by the Android is going to be executed there, and that's it. We go. Hardware abstract. Another just one more information is that in the past it was called the Dalvik Virtual Machine, since the first version was called like that, and it was having Dalvik code that was going to be executed, inside of we call it the Dalvik bytecode. So yeah, so it's going to be executing that Dalvik bytecode inside of that machine. Next one, the hardware abstraction layer. So it's just a simple bridge. It's a layer bridging up the higher level and the lower level, and it's just an interface between these two things. So essentially, it allows like the operating system to communicate with the hardware without needing to know like the specific details of I don't know each device hardware component. So, for example, if an application wants to take a photo of an Android on an Android device, it will use like the camera API provided by the Android framework, that's for sure, and the camera API will then communicate with the HAL. So you can just imagine that in your mind to access the camera driver and control the camera hardware to take the photo. So it's simple. We don't have just to complicate things too much, I think. So yeah, and the last layer is the Linux kernel. So the Linux kernel, I know everyone knows Linux. I guess most of my viewers know Linux. We've been dealing a lot with Linux. So Linux kernel is the one that is going to be interacting directly with the hardware. Now the question is, I already said that I guess in the stream, but I will say it again. Like why the hell do we even use like Linux? So why don't we use Windows, for example, or why won't we use another like operating system we can invent? So the answer is just pretty simple. Linux just is good as doing this job. So if you can find something better than Linux, then yeah, welcome. Get it. We can do it. We can just install it and just get rid of the Linux. But for now, Linux is just the best thing that we can use to interact with any kind of hardware. So if you are making an operating system above Linux, then you just have to implement those layers by your operating system and then just let Linux deal with the hardware thing and just interact with it. So Linux is a good way because it's also taking or doing some security measures above that. So we make sure that any kind of operation that is going to be happening on the hardware is not going to be damaging the hardware. So for example, when you try to create an application that is going to be, let's say, exploding the phone when you are trying to call someone. I know some people are gonna be relating that to the pagers that we saw and think Lebanon if I'm not wrong. But For example, that's a good way to do it, to implement any kind of software that can do that. But I don't know what was the system that was going to be working on those pagers. But for this specific use, Linux will make sure that if you try to create an application that is going to be, for example, sending a high amount of energy, or trying to control the say the electronics inside of the hardware itself by trying to send a huge voltage to a specific component to explode it, Linux won't let the application do that because there's some security inside of it. We're not gonna be digging too much deeper right now on how Linux is doing this, but you just make sure to understand that Linux kernel is going to be guarding the hardware for now, and it's the one that is going to be communicating directly with the hardware. So it's going to be taking commands from the higher part and just executing, then getting the result in a safe way, in a secure way. Yeah. I hope just I managed somehow to explain to you like the different components of the Android like framework. So if you're still curious, you can just check like the documentation and read more about them. Yes, I guess that's it. So I think now it's time to move on into the components of some other components that make the let's say the application, but just from a high perspective in this video, and in the next video we dive more deeper inside of the creation of Android applications and stuff like that. Anyway, so yes. So the Android framework, and we have also other things which are the activity, and we have resource. So those are managers, for example, but I'm not going to be talking about managers right now. I'm going to be talking about the four components that make the Android applications, which are activity, service, broadcast receivers, and content providers. So those things really important to understand, guys, because those components are the ones that will be making the application, and you should know and understand what each one of them is going to be doing. So okay, now we can just try to understand them just one by one. For example, for the activity. So the activity, like guys, is a component that represents a single screen with a user interface. So it's one of the like four components that we should care about. So an activity is typically providing a window with the user can interact with the application, such as displaying, for example, text, images, other UI elements, and also handling like user input. So you can have, for example, many such that, for example, each of them defines the UI, and the interesting thing is that you can define which one of them is going to be the main activity, which is a word that you will hear a lot, and the other one are just second activity, third activity, or whatever. So we can just you can just, for example, here I try to create a simple project just for you to understand what an activity is. And for example, okay, the emulator is not working properly. Maybe it's just having a bug, I guess. We can try to relaunch the application, but either way, as you can see, for example, here this is the main activity. I'm not going to be diving too much inside of the code for now. Let's try to finish for first the theory, and then we can get more inside of what's happening inside of this code. So we need to see other things before we see this code. So for the main activity, so either way, so this is what a main activity is. This is, for example, another activity, and this one is another activity. So once the applications opens up, you can see them like on real time. Okay, the application is opened. Just a second. Wait a second. Just I want to show you like what a main activity is looks like actually. So this is like the second activity. So first segment, as you can see. So this is what a main activity is. So it's the main page that opens up when you try to open up your Android application. We usually call that the main activity, or you can just imagine it as the main function, for example, in a C code or a C++ code, where you have to where it's the function that is going to be where the RIP or the instruction pointer is going to be pointing to when he starts to execute a program. The same thing for Android application. The system is going to be searching for the main activity, obviously, to execute it as the first one too. Anyway, so this is what an activity is about. So we also have another component, which is a service. So a service component, guys, just is a type of component that runs in the background and performs like some operations or tasks to do not require user interaction, and that means they do not require UI. That's the thing. For example, you are I don't know scrolling into social media and you're listening to Spotify. So Spotify is having a music service that runs on the background of your phone. If you are not in the application, the music is just you're hearing the music in the background. So this is what a service is. We also have broadcast receivers. A broadcast receiver is a type of component that is designed to respond to a system-wide events. Its primary purpose, guys, is just to handle events. So, what happens when your battery is getting low? What happens when you plug in your charger? What happens when you get a phone call from your friend? So all those things are managed by something we call a broadcast receiver. We also have something called we can just type them in if you want, by the way. We can just type them in. So the first thing is activity. So the four com, component a component or whatever. Component activity, and the second one is broadcast receiver, and the third one is, well, the second one is actually services or service or whatever. And the fourth one is content provider. And the question is, what are content providers? So, a content provider is like a component that manages access to your data, and it provides a standard interface that allows like applications to query and modify the data that you have. Uh, for example, let's say your application wants to get access, for example, to your local images or something like that. So to do that, it requires you to give it, for example, the permission to have that. So we're gonna be saying we're gonna be seeing permissions in the next video. So when we are going to be talking fully about security. So, but for now, content provider is the component that is responsible in the Android to take care of anything related to storage. Okay, so yeah, so these various like components or these different components, using them we can develop different type of applications. And one more thing just to mention here is that each one of those components in Android has its own life cycle, and which is a crucial concept in the Android framework, guys, that you need to understand. So a life cycle is basically this thing. So you have, for example, your this is for example the life cycle of an activity. So there is also a life cycle of service, a life cycle of a content provider, a life cycle of a broadcast receiver. So I'm gonna be just showing you an example of an activity life cycle, and you can just project that into the different other components. So it's almost the same thing. For example, for the activity, so the first thing that we see is that the activity is launched. We create a new instance of this activity, then we start it, then we resume, and all those are functions or methods that are going to be used by the activity object. So on start, we can restart. When we restart, we start again. When we stop, we can either restart or kill the process. When we pause, we can resume or we can kill if it has a lower priority, and if we completely want to stop the process, we can destroy it. So it's just a simple life cycle. Yeah, you will see that, for example, in the code in here when we are going to be working with Android Studio. As we can see, the activity is having the onCreate function, and is also having, for example, those functions are related directly to the functionality of the application. But for example, we can see the onCreate, which is also part of the activity lifecycle. Anyway, so this is like what a life cycle is. Now the next thing that I want to talk about is intent. So intent. So what is an intent? So basically the question arises when you try to question yourself. We talked about the components. We saw the stack that the Android is having. What are the different questions that we can ask? Is that the first thing, how do the hell those applications are speaking with each other? So a good question actually. So they speak with each others using a mechanism, a high-level mechanism called intent. So we can just type in intent like that, just to see it. So it's just this way. So an intent, and we have two types of intent. So we have explicit intent and we have implicit intent. So the explicit intent is used to start a specific component such as a specific activity or service within your own application, and it's like telling your phone exactly which application you want to open and which screen you want to see within the application itself. So this type of intent, guys, is typically just used within your own applications as to navigate between different screens, or I don't know, start a background service or something like that. So we call it explicit intent. So this is an example of an intent you can make. You create an object from the class intent with, for example, second activity dot class, and you set the data. You can follow me, for example, at ironbyte dot tech, and you add up the arguments that you want, and you keep on adding arguments, and then you start the activity. So this is how you do, for example, an intent to an activity. You can do the same thing, for example, if you want to a service. You can do the same thing to a broadcast receiver, and you can do also the same thing if you want to a content provider. So intent is a higher level mechanism that can help you do this from a developer side. We're gonna be getting deeper inside of this intent. Don't worry, there is something also interesting, a lower level mechanism called Bender that is underneath working. We're gonna be seeing that in the next video. We're gonna be talking more about that Bender. Anyway, for now, just we have explicit intent and we have also implicit intent. So the implicit intent, guys, is used to request the, like the action from other application of the device. So it's like telling your phone what you want to do and letting him figure out which application can do it for you. For example, like if you want to share a photo from your gallery app, and you type in, you just tap on the share button inside of the gallery settings, it poops up for you different applications to use. So this is the way how your phone's just figuring out that it's like telling you, hey, you can use Instagram to share your photo, you can use Facebook, you can use WhatsApp, you can use, you know, those applications. That's the thing. How the hell is your phone differentiating those applications? For example, if I have, for example, Subway server, serves, I'm sorry, let's say I have a game, not necessarily Subway. For example, I have a game. The game usually doesn't have the ability to process the image that I'm gonna be sharing. So we need to find a way. So the thing is that we need to find a way to differentiate applications who accept pictures and who have the ability to do specific actions. That's called intent filter. We will be seeing that also, which is this one. So the implicit intent so is basically to the outside applications, and we for example in this thing we created an URL with this just link. We create a new intent. We say that we want action view, which means that we want to see this application or this we want to access into this link. So we set the data and we start the activity. So the thing is that he's going to be popping up to you the different browsers that you have, since they have this intent, so they can actually process this action. So most of the browsers are having an intent filter, which is in this format on the application that says for them that anyone who wants to have the action view or apply or execute the action view can use me. So this is the utility of intent filters. For example, we have this Android filter, intent filter, where it's going to be treating the action.view and the default, and any kind of images can be used by this application. So you actually there is another thing that we should care about inside of the application, which is actually the manifest. So the Android manifest. So the Android manifest, guys, is a really important thing to check out whenever you are trying to understand how those Android applications are working. So, for example, if you are trying, we will see that a lot, especially when we go into the practice side. But for now, when you are trying to understand any kind of Android application, the first thing you just check out before anything else is just to look inside of the Android manifest, because it's going to be giving you a lot of informations about the application itself. So, for example, this is the Android manifest. For example, we can't see anything related to the intent filter, but we have, for example, something related to an activity. So for example, this application is having an activity. So we said that we should be having four components, but not necessarily the four components in one application. So for example, an application can have a service and can have an activity, but can't be having, for example, a component using the content provider or broadcast receiver. Just an example. But for this one, we have an activity for sure that is going to be having like an intent filter with the main, which means that anything that is going to be using launcher or something, this application can be used for. So those are the actions that this application can accept. Okay, so yeah, so that's the thing for intents. So the next thing that we should care also about is the API version of the application. So for example, this application is going to be using the API 31, and to fully understand what those API are exactly. So in the process of developing the Android platform version, we usually care about the API because Java is still maintained by Oracle. So Oracle is maintaining the Java project. So there is some patches that are going to be happening to the functions, to the APIs, and to those things, improvements, and a lot of shit is going to be happening inside of this Java world. So the same goes for Android too. Whenever we are releasing a new version of Android, we get a new API level. And the thing that you should understand is that when you compile an Android or you build an Android application, specifically APK, that we're going to be diving more inside of the next video. The more so when you build an APK, for example, on the API 21, you can't be running this application, or it's going to be running in a bad way. For example, when it's going to be executed on an older version of that API, for example, on the API 19, 18, 17, or whatever. So that's why you should be running your application on something that works on the same level of API or on a higher API level. So that's the thing you should be caring about. So for example, when you are trying to reverse engineer an application that uses the API 21, you're not going to be using an emulator that uses the API 17 or 16 or 15 or whatever. You should be using an emulator that uses the API 21 or above 21. So that's the moral of this story. Either way. I think that's it for now. We've already saw like the different components that make the Android system, and yeah, I guess we are there. We are just trying to begin a new series of videos. I guess like this is a great introduction to anyone who doesn't know Android, I guess. I guess now you should be able to understand that Android has layers. Your phone has is your not your phone. Your application, your Android application is composed of components. You should know those components, and you should know also how the applications are communicating with each other from, this video is from a developer side. I felt like it was more like into developing and understanding, just mainly. I didn't dive too much inside of the code because this is just pure Java. If you can just read Java, you should be able to understand what those things are. It's not that complicated, I guess. But the moral of the story is that you should be having the curiosity to understand how this Android system, it's a journey, like the same one as we did with the reverse engineering series, and the same one like as we did in the micro corruption one. If you have watched it, it's a journey. We're gonna be trying to learn step by step, dissect whenever we have the chance, get in depth also whenever we have a chance. That's the methodology I guess I've been using. If you are also a fan of that, then I'm sure you will be just finishing all the videos I make. Yeah, I think we hit the end of the video. You can just follow me on Twitter, Instagram, LinkedIn, connect with me too. You also have the Discord server. Just people are hanging up there. They're sending the memes. You can just game too. Yes, and if you have also any kind of question, you can just ask me private. Yeah. Bye.